All right, I'd like to do another problem with you now on Bayes' theorem. So let's take a look at number 4. So it's problem 4 on page 108 or so. Let's go over to PowerPoint and I can show it to you a little bit larger. So your firm's considering the introduction of a new toothpaste. At a strategy session, it's agreed that the marketing study will be successful with probability 0.65. So what I take this to mean is that the marketing research that we do is going to tell us that we should go forward with the launch with probability 0.65. It's also agreed that the probability of a successful launch is 0.4. However, given that the marketing study is successful, the chance that a launch is successful is 0.55. So how are we going to solve this? Well, we're going to make a crosstab out of it. So the first step in doing so is to identify what's given. And let's look at this statement. The marketing study will be successful with probability 0.65. So there's an event in here. So that event is that the marketing research says go forward with the launch. So let's have that event be G, and that probability is 0.65. Now let's read on. The chance of a successful launch is 0.4. Well, there's an event here as well. That event let's call S, which is that we have a successful launch. Probability of a successful launch is 0.4. Now let's look at the last part. Given that the marketing study is successful, so that word given is really important. As soon as you see the word given, you know that you have a conditional probability. So we're given success, so therefore, that's the go for it, G. The probability of a successful launch is now 0.55, and we can write that as probability of S given G is 0.55. Step 2 is to complete the crosstab. So first thing we do to complete a crosstab is enter all marginals. So I've entered in the probability of a successful launch, 0.4, as well as the probability that the marketing research says go forth with the launch, which is 0.65. The next step is to find the other marginals. So remember, everything has to add up to 1. Therefore, the probability that a launch is not successful is 1 minus 0.4, 0.6. The chance that we have a not, the market research says don't do it is 0.35. The next step is to enter only joint probabilities into the table. But we have a problem because we were not given a joint probability. We were given a conditional probability. So what we have to do is to convert that conditional probability into a joint probability using this formula. So we were told the probability of a successful launch given that the market research said go for it. And if you do a little bit of math on the conditional probability definition, you get this formula. Therefore, we're going to deposit 0.3565 into that cell. So that's a really important step. Make sure you understand that. Now that we have that number, the rest of the table is easy. All the rows have to add up to the row totals, all the columns must add up to the column totals, and we can fill it in. Now if you get this far, my claim is that the rest of this problem is pretty easy. So let's go see that. What is the probability that the marketing study is successful and the product launch is successful? The key word here is and. That and indicates that we have a joint probability instead of a marginal or conditional probability. So let's just look at that. So the probability that you are both in G, so that means the market research says go for it, and we're in S, right, is this cell right here. So the trick is recognizing you got a joint probability and then finding it in the table. Let's look at part B. Given. All right, well, as soon as you see the word given, you know you have a conditional probability. So given the product launch succeeds means that you are in that column. So we don't care about the whole table, we only care about that column. So given that you're in that column, find the conditional probability that the marketing study was favorable. So what that says is you want to know how big is this cell relative to the column. So we take 0.3575 divided by 0.4, 89%. Part C. Now find the conditional probability. So again, the word conditional probability is telling you the sort of probability that you have to find. So the product launch is successful. What's the probability that the launch is successful given the marketing study was not successful? So what that says is, let's say that you're in this row where the marketing study says don't do it. So if the marketing study says don't do it, what's the chance that you still have a winner? You know, that if you're missing an opportunity in essence. So that would be how big is this cell, 0.0425, relative to the row. And so there's about a 12% chance that if the marketing research comes back and says don't do this, that you're really missing an opportunity. Part D asks whether the events that the study is successful and the product launch is successful are independent. Well, let's recall that A and B are independent if and only if the conditional probability is equal to the marginal probability. So let's just take a conditional probability that we have and compare that with a marginal that we have. So let's think about the chance of a successful launch. So the chance of a successful launch is 0.4. Now if they're independent, the chance of of a successful launch, given that the marketing study said that we should go for it, is would still equal 0.4. But clearly that's not the case, since we're told that that conditional probability is 0.65. Therefore, the events are not independent. So that's it for this problem. I would suggest trying this on your own now.